Last video, we talked about growth and development of bones, especially at the epiphyseal growth plate. That's where we left off. So let's talk a little bit more about that process. You have growth and development at your epiphyseal growth plate, and that is happening by two different processes that are working at the same time in concert with one another. You have the breakdown of that calcified material, and then you have that building up of that calcified material. When you see clasts, CLASTS, at the end of the word, think of uh, um, a cell that tears something down or breaks something apart. So osteoclasts are bone breaking down cells or cells that break down the bony matrix in bone. Osteoblasts, as I mentioned in the last video, blasts build. So osteoblasts are cells that build bone material. What osteoblasts do is they invade the area and then they start to deposit that bony tissue in that cartilage, creating a harder calcified cartilage. Whereas osteoclasts will go into a bone area and start breaking things down that either that bone does not need anymore. For example, if you were a person who walked up a certain number of stairs for years. When you first start walking up those flights of stairs, it's going to be a little bit more difficult as your bones and your muscles adjust to that stress. But then let's say you change jobs and you no longer have to walk up those flights of stairs anymore. You don't need that extra reinforcement that your bones and muscles have built up unless you find some more stairs to climb. And since you don't need that anymore, the body says, all right, I don't need this anymore. Let's go ahead and remove it so that we can use that raw material elsewhere, and continue to have the bone that's necessary for the amount of activity and stress we have on ourselves now. So if you have something that is no longer needed, the osteoclast will come in, break down that part of the bone to redistribute those raw materials into other areas of your body or to get rid of it if your body no longer needs it. Your long bones will continue to lengthen as the cartilage cells of the epiphyseal plate remain active. So as long as these cartilaginous cells that are located inside the epiphyseal plate are active, your bones will continue to get longer. Once the ossification centers of the diaphysis and the epiphysis meet up, so remember you had one of them, the primary ossification center in the diaphysis or the shaft of the bone. You have that secondary ossification center in the spongy bone or the epiphyses of the bone, and they have that cartilaginous space in between them that didn't show up in the x-rays. Once these two centers meet, that metaphysis, that physis, that growth plate in between the two will itself start to ossify. Once that ossifies, there's no longer any growth because you no longer have those cartilaginous cells that are going to keep building. That portion of the bone is now ossified. That bone can no longer get longer. Now, that doesn't mean that osteoclast and osteoblast stop working. They continue to work throughout your entire life, but that looks a little bit different as you get older than it does when you were younger because you no longer have that growth plate in between your epiphyses and your diaphysis. In this case, your bones can begin to thicken, um, in order to deposit that compact bone on the outside. All right. So after your growth plates close, the osteoblast and osteoclast activity occurs due to either repair of the bones. Say you got into a motor vehicle accident, you played sports and your bones got injured somehow, or you just started exercising and your body needs some reinforcement. In those cases, the osteoclasts and osteoblasts are going to come in, start to remodel those bones. The osteoclasts are going to shave off whatever pieces don't need to be there. The osteoblast is going to come in and lay down some more calcified matrix that is more specific to the what's the word, the stress or activity that you're currently doing in order to build those bones up to what you need. It's not getting longer, but it's continuing to strengthen according to your activity level. Now, this is just a snapshot of the ossification timeline so that you can see at what stage bones start to ossify or harden. Now, this begins while you are still growing in mom's belly. So, 3 months of prenatal development. This is the end of the first trimester, where the long bones will begin to ossify. By that fourth month or the beginning of the second trimester of development, excuse me, most of the primary ossification centers have appeared in the diaphyses of the bones. They're there, they're starting to ossify. That doesn't necessarily mean that they've completed ossification process. They've started it. From birth to 5 years, your secondary ossification centers will appear in those epiphyses. And then from 5 to 25 years, you have different levels of ossification that are spreading, that different lengths of time that it takes to completely ossify the upper limbs, the lower limbs, and the other bones throughout the body. By the time you are 25, 23 to 25, depending on gender, nearly all of your bones have ossified. So those of you who are under 25 years old, know that you do still have some bones that are still has some level of cartilage in them. They're still ossifying. And for some of you, you still have growth occurring. So you may get taller because your growth plates are still growing, but these but the bones themselves are also still ossifying. Let's talk about homeostasis. You should remember homeostasis from any biology and chemistry classes that you've taken in the past. Homeostasis is the process by which your body is trying to develop and maintain balance. All right, so that's the process of homeostasis overall. Even in your bone tissue, your body is trying to maintain a certain level of balance. And that's going to happen through bone remodeling, which is what I talked about a little bit earlier. So you have this model of bone, you have these bones that are set. And then as something changes in your life and in your body, again, whether that is a traumatic accident, a break, a fall, an injury, or it's just you are changing the level of activity that you're doing, either more or less activity, your bone is going to begin the remodeling process throughout your entire life to keep up with what is necessary for your bones in that moment. You have opposing processes of deposition or things being laid down in the bony matrix, and resorption, things are being pulled out of that bony matrix that occurs on the surfaces of both the endosteum and the periosteum. Bone resorption is what it is occurring through the activity of osteoclasts. Remember, clasts tear things down. So your body starts to remove some of um, that bony material, those inorganic salts and other material through the activity of osteoclasts in order to help remodel that bone. And then the body deposits or lays down new bony material, new inorganic salts in order to build bone up. And that happens through the process of the osteoblasts. Bone remodeling is not uniform. So it doesn't occur at the same rate and the same time across all bones. It really depends on the types of bones that we are talking about, and probably the needs of the bone. So spongy bone lays down faster than compact bone, which to me makes sense because compact bone is more compact. It is more dense. It does have more extracellular matrix laid down in between each cell. Then the spongy bone. The reason why spongy bone is spongy is because you have those trabeculae and lots of spaces in between. And so because spongy bone has lots of spaces, you have you have less material for these osteoblasts to have to remodel in the bone. After you finish growing, so after you finish getting taller and your growth plates have closed, because of homeostasis and your body trying to maintain balance, your total bone mass, the mass of all of your bone tissue throughout your body, remains roughly constant and consistent throughout the remainder of your adult life, unless something changes along the way later on in life. So this basically means that as your bones are resorbing calcium and other inorganic materials, it should also be depositing calcium and inorganic materials to help strengthen your bones and repair bones. So this is a tight regulation that occurs because of homeostasis throughout your adult life, so that you should not see a net gain or net loss unless there are some extenuating circumstances, either in the way you are building bone or the way you're tearing down bone. Roughly 10 to 20% of your entire skeleton is replaced or remodeled each year. As an aside, just know that that amount of your skeleton is being remodeled every year. So, in the span of 5 to 10 years, you have a new skeleton. Every 5 to 10 years, you have a new skeleton. Some things that can affect bone development, growth, and repair. There can be many different things that affect how your bones grow, how your bones develop, and whether or not your bones can repair adequately. Primarily, we're going to, well, the first thing, not primarily necessarily, but the first thing is nutrition. Remember that the reason we eat food, the reason why we shovel all the things in our mouths that we do is not necessarily because it tastes good. Now, we do eat because it tastes good, but the reason why food tastes good and we want to eat is because our body needs the raw materials that nutrition provides in order to build your body up. So, the calcium, the magnesium, the phosphorus, the biotin, all of those things that our bodies use to build up bone in the rest of our bodies, we get that from the food that we eat. So, the more nutritious the food is that we eat, the more raw materials we have for better repair, growth, and development of our bones and other structures in our body. Remember, sunlight exposure is important for vitamin D levels. So that absolutely has function in how our bones develop. We have our hormones, and then we have physical exercise. So let's talk a little bit about some of these. Your vitamin D. Remember, vitamin D in and of itself is not going to affect how the bones develop, not by itself. What it's going to do is it's going to affect how your body absorbs calcium. So if you don't have adequate amounts of vitamin D in your body, you are not going to be able to absorb as much calcium as you could from the foods that you're eating. If you're not absorbing as much calcium, this is going to lead to weaker bones because you don't have that hardened calcium, that calcium that has hardened to create the bones. So in children, this can cause a condition called rickets. In elders, this is called osteomalacia. I want you to look up malacia, Malacia, so you can type in define and then put in quotes Malacia, Malacia, so that you can see what it means. The word basically roughly translates to bad bones. All right. So lack of vitamin D can cause weakening of bones in both children and adults because of the effect that it has on calcium absorption. You have vitamin A. Vitamin A is responsible for both osteoblast and osteoclast activity. So if you lack vitamin A, then your bones won't be able to develop, repair, grow as well because you don't have that osteoblast and osteoclast activity going. Vitamin C is necessary for collagen synthesis. So anytime you see supplements for collagen or skin or bones, usually you'll see vitamin C in that supplement. When you're talking about collagen for skin development, oftentimes you'll see serums and oils and potions and things like that. And oftentimes you'll have a vitamin C serum so that that vitamin C can be absorbed into the body and help with this collagen synthesis. And you should remember that collagen not only helps your skin to be firm and plump and supple, but it also is part of what makes up your bones. So the more vitamin C you have available, the stronger your bones can be because of this collagen synthesis. If you have a deficiency of vitamin C, you will have abnormally slender and fragile bones. Proteins are necessary, so we have to get proteins either from a vegetable source or an animal source, meat or vegetables. Both can give you protein, and that helps your body to build collagen. Remember that collagen is a type of protein, and collagen makes up 90% of your bones. So, in order to have strong bones, not only do you need vitamin D, vitamin A, vitamin C, you also need proteins that are going to make up collagen that makes up most of your bones. Now we have growth hormone. Growth hormone is a hormone that your body produces. It's secreted by a pituitary, this little nubbin that's this little dangleberry, this little dangle nubbin that is in your brain. This pituitary, we'll talk a little bit, well, we'll talk a lot more about it when we get to the endocrine section. But the pituitary is called the master gland. And the reason why it's called the master gland is because the pituitary itself secretes several different types of hormones that control other glands throughout the body. One of those is growth hormone. Growth hormone does just like it says, it is a hormone that is responsible for helping the body to grow. It stimulates your cartilage cell division in those epiphyseal plates. So if a child does not produce growth hormone or a child produces inadequate levels of growth hormone, that will be a child who ends up being a dwarf. They do not grow taller because they don't have the stimulation of the growth plates, the cartilage cells in the growth plate by growth hormone. Insufficiency in children produces pituitary dwarfism. Because remember, the growth plates are open, it's just not growing because it doesn't have growth hormone. If you have an excess of growth hormone in children, remember, again, it's because these growth plates are still open. These children's bones will continue to grow longer and longer and longer, where they end up having pituitary gigantism. So, gigantism, meaning they become giants, very, very tall people, because of excess production of growth hormone by the pituitary. Now, if this excess production of growth hormone occurs in an adult, say as children, they grew just fine, their growth plates closed when it was supposed to close, the end, they're no longer growing taller, they're going about their business, and they develop a tumor. for example, in the pituitary, a tumor of specifically the cells that produce growth hormone. When this happens, growth hormone will be secreted and an excess will be secreted. But because adults no longer have a growth plate in order to make growth, in order to make bones grow longer, it still affects the bones. They're just not going to grow longer. What they're going to do is they're going to grow thicker. And so this causes a condition called acromegaly. Acromegaly. So it's a similar process as pituitary gigantism, but the difference is that in the children, the growth plates in the bones are still active, so the bones can grow longer. In the adults, the growth plate has ossified, so it's stopped acting, and so the bones grow thicker instead of longer. These are examples of people with these conditions. So in this picture on the left, you see this guy here. His tallest growth was 2 feet 5+ inches. He was only 2 feet tall. He was the shortest man in the world because his pituitary did not produce growth hormone. And because apparently they did not catch it when he was younger, they could not administer a growth hormone medication. So he only grew to a little over 2 feet. Whereas this guy, Sultan Kozin, on the right of this first picture, he grew 8+ feet because his growth plates were still open. So all of his bones got extremely long before his growth plates closed. Now, the picture on the right, for those of you who were into wrestling, this is Andre the Giant. He was a wrestler and an actor that had acromegaly. So basically, and I don't know, he may have had some form of this right before his growth plates closed because he was a really tall guy. But as he got older and his growth plates closed, he continued to have this effect on his bones the uh, of the growth hormone. And so he developed this telltale appearance of the bones that have gotten thicker. And so this person is showing you an image of what that typical look of a person with acromegaly looks like. So if you're interested, go ahead in your textbook and look up dwarfism, gigantism, and acromegaly so you can get a better understanding of them. Some hormones that will also affect bone growth, some other hormones. We already talked about the pituitary secreting growth hormone that stimulates the cartilage cells in that growth plate or physis. It's also important that other hormones are working adequately in children in order to have their bones grow, develop, and repair properly. Excuse me. The thyroid. The thyroid secretes thyroxine or T4. Thyroxine is one of the hormones that your thyroid will produce. Thyroxine is the inactive form of your thyroid hormone that we think of as thyroid hormone. This T4 will stimulate your osteoblasts to be more active, and it will help to replace that cartilage in the bones. So if the child or the person has low functioning thyroid where they're not producing adequate levels of T4, then these osteoblasts won't be stimulated or they won't be stimulated adequately. So the bones cannot grow in that growth plate. The parathyroid gland is not the same as the thyroid gland. The parathyroid gland sits on the thyroid gland. And again, we'll talk about this more when we talk about the endocrine system. It secretes parathyroid hormone. The parathyroid hormone stimulates osteoclasts. Remember, clasts break things down or tears down. So the osteoclasts are going to break down the bone in order to help remodel it. Sex hormones also affect your bone growth, so estrogen and testosterone. And it's actually quite interesting how this happens. This sort of explains why males tend to be taller than females. So, estrogen and testosterone will promote bone formation at puberty. They stimulate ossification at your growth plates, which will stop bone lengthening. So it stimulates ossification at your growth plates. All right. So let me repeat that. Sex hormones will promote bone formation at puberty, which will stimulate the ossification of the growth plate, and that stops bone lengthening because you're starting to ossify or harden the growth plates. Estrogens tend to have a stronger effect on these growth plates than testosterone. This is why females tend to have their maximum height earlier than males. So for females, the height that they are when they develop or when they go into puberty is pretty close to the height that they're going to be for the rest of their adult life. This is why girls tend to be taller than boys around that puberty, prepubescent age because of this kind of growth. Whereas testosterone tends to cause growth spurts. So when boys enter puberty, that's when they tend to have these growth spurts because the testosterone is stimulating bone growth and bone lengthening, whereas estrogens are having a stronger effect by um, ossifying these growth plates earlier. Physical stress or physical exercise also stimulates bone growth. So, athletes tend to have stronger bones and heavier bones than non athletes because the body is paying attention to what your needs are, what you are doing. It wants to maintain homeostasis. It wants to have bones that are going to be adequately effective for whatever activity you're doing. So, the more activity you have, the stronger your bones will become. And once you stop exercising, especially if you stop for long periods of time, your bones will start to resorb and your bones will not be as heavy or as strong because you're no longer needing it. So that is hormones and exercise or physical stress. This is an image that should help you understand this process of ossification. So when we talk in lab, especially, but when we also talked about bone development, we talked about the projections, the dips and the holes inside of bones. And when you have a projection on a bone, that is usually the site of muscle and tendon attachment onto that bone. So you'll notice here, these are two femurs, these are two leg bones side by side from two different people. You'll notice that this one has more of these gnarly projections or these knobby projections than this one does. So this one actually does have it, but it's not as prominent as it is here. And what this is showing you is that this person was likely an athlete or did a lot of physical work because at the places where these muscles attach to the bones, the muscles were likely under more stress. And so it was pulling on those bones more, which caused the bones. Remember, your body is very, very observant and it's going to try to um, build itself up to maintain so that it can withstand whatever stress you have. And that is what happened here. This line has gotten bigger than in this person because there was more stress at the site of muscle attachment to bone due to exercise. So now we're going to talk about fractures. These are breaks in bones, whether they are slight breaks or they're complete breaks. That's what a fracture is. And bones fractures can be classified by both how they're caused and what they look like. So the classification by cause, either a person has a trauma or they have some disease process. So traumatic cause be, occurs because of injury. So this is your motor vehicle accident. This is your falling from a height or falling at an odd angle. This is your athlete breaking a bone because of the sport. These are traumatic causes caused by injury. Your spontaneous or pathologic causes occur because of some disease. So, osteogenesis imperfecta would be an example of a disease that leaves the bones more, what's the word? More susceptible to breaks and fractures because of whatever disease the disease process is. In the case of osteogenesis imperfecta, it's because that collagen is not formed as strong as it should be. And so this leaves the person with more brittle bones that are more susceptible to breaks. Then you have the nature of the break. So, what does the break look like? You have closed fractures and you have open fractures. A closed fracture is called a simple fracture. These are the fractures that you don't see. This is protected by uninjured skin. So, most of the time, when we see somebody with a bone break, it's a closed fracture because you don't actually see the broken bone, but it is there. It's usually covered by either uninjured skin or uninjured mucous membranes that cover it, as opposed to an open or compound fracture in which the bone is exposed to the outside through a break in the skin or the mucous membrane. So when someone has that severe type of break and you can actually see the bone, that is a compound or open fracture. So this is what these look like. You have this one called your green stick fracture. The green stick fracture is an incomplete fracture. The break occurs on the convex surface of the bend in a bone. All right. You have a fissured fracture. Remember what a fissure is. If you don't remember, please go look up the word fissure because we've seen it several times before. A fissured fracture is where you have an incomplete bone, break in a bone that is longitudinal. So you notice that this bone, this fracture goes the length or up the length, not maybe not the entire length of the bone, but it goes up the length of the bone. That is a fissured fracture. It is a simple fracture because it doesn't break the skin, but there is some kind of fracture in the bone. You have a comminuted fracture. Comminuted fracture is when you have bone that shatters. All right, so now you have a bunch of little fragments of bone inside the body, but because these are simple fractures, they're still encased within that structure. You can't see it, but it is, you do still have those bone fractures in that area. You have a transverse fracture. Remember, transverse is across. A transverse fracture is a complete fracture, meaning that it goes across the entirety of that bone structure. A comminuted fracture is also a complete fracture because the entirety of this, the width of this structure is broken. I don't know if I mentioned that these are incomplete structures because I'm sorry, fractures because these don't go across the entire width of the bone, right? So this green stick fracture is occurring on one side. Remember, this is occurring on the convex surface right here. And this one is a fissure. So it's just that length of a fracture. Whereas this transverse fracture, transverse across, it goes across the entirety of that bone. Um, it usually occurs at a right angle to the axis of the bone. So it is going to go perpendicular to the long axis of this bone. Then you have the oblique fracture. The oblique fracture is one that occurs at an angle other than a right angle in at an angle to the axis of the bone. All right, but it is a complete fracture, so it is going from one end to the other. Then you have your spiral fracture. This is occurring because of some excessive twisting of the bone. It could be that a person planted their feet and spun around, and if there was some kind of weakness in the bone already, then that bone can spiral and fracture. Or if someone was yanking a child or twisting an arm, literally, or something like that, that can cause this spiral fracture in the bone. So, this is how your fractures are repaired. All right, this is how your fractures are generally repaired in your body. You have a hematoma. So, hemat means blood. Oma refers to a tumor. Now, when you see oma, that does not necessarily mean cancer. It just means tumor, and a tumor is not always cancerous. So, a hematoma is a blood tumor, also known as a large blood clot. So the blood clot forms right after the fracture occurs. Remember that when a fracture occurs, you're breaking blood vessels that run through the bone. So those blood vessels will leak blood into that surrounding area until it'll leak blood until there is clotting of the bone to, I'm sorry, clotting of those vessels to stop the blood from flowing out of the vessel. That blood gets into that area of the break and forms this blood clot called a hematoma. You have a cartilaginous callus, all right? So a soft callus. Osteoblast will come into the area and it will produce spongy bone. Then you have phagocytes, those white blood cells that go in to gobble up and remove the debris or the excess bony material and other material that's not supposed to be there. And your fibrocartilage is produced in that area. So you have cells that go in and remove the debris out of the way, whereas these osteoblasts will start to invade and produce spongy bone, and that fibrocartilage is produced. Then you have, so that's the soft callus. Then you have your hard callus. So the cartilaginous callus or the soft callus starts to break down, so that you can think of this as the first band-aid that is put over the area. It is a softer one. And then, sorry about that. And then you have that it did what it was supposed to do, kind of patched up the area. And now you can have osteoblasts, more osteoblasts come in, start to remove the soft cartilaginous callus that starts to break down. The osteoblasts then start to go in, invade the area, and to make a hard um, extracellular matrix now to fill that space. Then you have remodeling, where the bone is restored to its original shape as the osteoclasts remove that excess bone that was used as the scaffolding to help create the bone. So the steps in fracture are hematoma, cartilaginous soft calcium, callus. Let me repeat that: hematoma, cartilaginous soft callus, and then you have your bony hard callus, and then there's the remodeling. So this is an image of those steps. You have the hematoma in this top left picture, or A, where the blood vessels leaked blood into the area. And then it formed a blood clot that eventually helped these blood vessels to stop leaking blood into the area. Then you had that soft callus to form in this area. So you have spongy bone developing where that blood clot was. While that's occurring, the new blood vessels are forming so that they are continuous on either side of the break, so that all parts of the bone can now continue to get a blood supply after the injury. That soft, spongy bone callus is now going to be replaced by a hard bone. And then all that excess space that was put down to help repair it, the excess bone, is remodeled so that you don't have as much excess around that bone because it's now being been repaired. So functions of the bone, as you should have either already read or figured out, it provides shape for your body. So you have the body shape that you have because your bones are shaped with the way they are. And then, of course, you have your muscles, your connective tissue, your skin laid on top of those. But the bones form that primary shaping model. It supports your body structures, so your muscles attach to them and they're able to function because of this support that they give. It protects your body structures like your the organs in your thoracic cavity, the organs in your pelvic cavity. It aids in body movements. So your muscles can do what they do because the muscles are attached to bone, and that can help you get where you need to go. It contains tissue that produces blood cells so that that bone marrow in the epiphysis and diaphysis of your bone is where your bone is produced, and your bones store those inorganic salts that are there to help strengthen the bone, but they're also there as a reservoir for later use if your body needs those nutrients for other processes. So your bones provide shape for your head, face, thorax, and limbs, as mentioned. Um, It supports your body weight, so your bones of your lower limbs, your vertebral column, especially those bones in the lower vertebral column, those lumbar bones, the sacrum, etc. Your pelvis, your limbs, especially your lower limbs, all of those support the weight of your body. Um, and then it protects those other organs. So now let's talk about blood cell formation. We mentioned that your bone marrow is the site of blood, the site of blood formation in your body. This process is called hematopoiesis, also called hemopoiesis. You'll see both terms used in throughout biology and medicine, so know both terms. Make sure that you look up poiesis, poiesis. So define. So you can do a Google search for something like define poiesis and put poiesis in quotation marks so that it can search just for that definition. This is the process of, excuse me, blood cell formation. This process actually begins in the yolk sac. So when you are very young, newly developed in the womb, your blood cells will start to form. All right. Sometimes even before mom knows that she's pregnant, you'll have the process of blood cell formation beginning. Remember that you have two different types of bone marrow. You have red bone marrow that we typically know about, and you have yellow bone marrow. Red bone marrow is where red blood cells are formed. That is why it's red, because you have more of your erythrocytes or red blood cells being formed in these tissues. You also have the formation of white blood cells, which are leukocytes. Leuko means white, cyte means cell, of course. So leukocytes are your white blood cells. And your blood platelets are also being formed in your red bone marrow. Now, what makes red blood cells or erythrocytes that typical red color is hemoglobin. Hemoglobin is a pigment that is red that allows the cell to carry oxygen from one place to another. If your cells did not have hemoglobin, it would not be able to carry as much oxygen throughout your body, and your cells will become oxygen deprived. Now, if you want to think about this process even a step further, think about how your body uses oxygen. Oxygen is the reason why we make abundant amounts of ATP in the mitochondria. So when this hemoglobin is carrying oxygen, throughout the body, it's carrying that oxygen so that the cells that need it can take that oxygen, bring it into itself, bring those oxygen molecules into the mitochondria, and that mitochondria can produce abundant amounts of ATP to help the cells function. All right. So just keep that in mind as a way to connect all of these processes together. Your yellow bone marrow is what replaces much of your red bone marrow as you age. Your yellow bone marrow does not produce blood cells. It's yellow because that is the color of fat. Yellow bone marrow is primarily there to store fat. So it replaces your red bone marrow more and more as you get older, so that you're producing less red blood cells or less formed elements in your blood, and you are storing more fat um, in your bones. Remember that bones, again, are a place of storage of inorganic salts. This accounts for approximately 70% of the extracellular matrix by weight. So, of the extracellular matrix found in your bones, 70%, roughly 70% of that is made up of these inorganic salts that are hardening or ossifying or calcifying your bones. These are mostly small crystals that are made up of calcium phosphate. So this is a calcium salt. And this particular calcium salt is called hydroxyapatite. So I want you to start paying attention to these supplements supplements and medications that you see being promoted for strengthening of bones or repairing of bones. And you'll probably notice that they are made of hydroxyapatite or calcium phosphate. Some other salts that the bones will store are your magnesium ions, your sodium ions, potassium ions, and carbon ions. So whereas calcium is the predominant inorganic salt found in bones, it is not the only one. And if a person wants to have adequately strong bones, that person will need to have all of these raw materials available to deposit in the bones in order to have the strongest bones possible. So the moral of the story is eat your vegetables, eat your vegetables, eat foods that have high amounts of nutrients so that you can build stronger bones and other things. So, how do we prevent these fractures? Um, if someone has a fracture that occurs from a fall that is less than standing height. So let's say you are a person that is 5'6". If you are sitting or you're laying down, you're in a position where you are not quite 5 feet off the ground and not quite 5 feet 6 inches off the ground, but you fall and you break a bone, then you likely have low bone density. So when elders fall and they break a hip, it could be because they already had these low density bones already, right? They might have already had these low density bones. So they're in these heights that should not affect it. If you were to slip out of your chair, you, as a younger person who is healthy and stronger, tend to not break a bone from slipping out of a chair because your bones have higher density. But as you get older, if your bone density gets low enough, then that same slip out of off a chair or something less than standing height can cause fracture. Bone remodeling, remember, occurs throughout life. So even after your growth plates close, your bones are continuing to remodel according to what's going on in your body at the time. With age, your osteoclasts start to remove more bone than osteoblasts deposit. Now, some of this process can be slowed down by staying active, continuing to exercise, continuing to give osteoblasts something to do well into adulthood so that they don't just stop working or slow down. Um, then you can slow this process down. And of course, having all the raw materials in balance is also going to be helpful. If the osteoclasts continue to remove more of the bone than the osteoblasts actually deposit, then that person can end up with osteopenia, with some level of bone loss or lower amounts of bone loss, or it can progress to osteoporosis, where they have severe or more severe bone loss that can leave spaces and canals in the bone that will then greatly weaken the bones. It's estimated that approximately 50% of women and 25% of men over 50 have one of the bone loss conditions. The reason this number is higher in women is because of this next line. After menopause, because of the shifts in hormones, the decrease in estrogen and progesterone, which help to strengthen the bones as we were younger, because these hormones will start to decline, then among other things, it will affect how the bones build, and um, if she's not careful, will lead to osteopenia and osteoporosis at a greater rate than it does for men, because our uh, estrogen progesterone drops are more significant in women, of course, than men, because men don't have as much of it as women. In order to prevent fragility fractures, continue to exercise throughout the rest of your life. So if you can start to get in the habit of exercising now, doing activities you love, doing activities that become more habitual for you so you don't have to think about it, exercise a little bit every day, be active and move. Including weight bearing exercises, that's going to help these osteoblasts to consistently build bone according to the stressors that you are putting on it. Make sure that you're eating foods that are high in calcium, and make sure that you are getting adequate vitamin D, including sun exposure, so that your body can make adequate levels of vitamin D, so that whatever calcium you are taking in, you can absorb it so that your body can continue to put that into your bones, deposit it into your bones to make them stronger. And do what you can to not smoke as you get older, because smoking weakens the bones greatly. Those people who smoke, the longer they smoke, and I don't know that it matters what you smoke, whether you smoke a cigarette or cigarette weed or whatever you decide to smoke. The more you smoke, the more um, the chemicals caused by the burning of the plant material gets into your lungs and into your bloodstream, and that can help to weaken the bones. So this is just an FYI. Sign of dangerously low bone density is these fragility fractures. Um, Again, if your bones are strong and healthy, if you have one of these lower height falls, you shouldn't have a problem. But if you have a problem from a lower height fall, that is one of those telltale signs of uh, low bone density. Osteopenia and osteoporosis are conditions resulting from loss of bone mineralization. So bone material has been resorbed and brought back into circulation for whatever reason, leaving the bones less strong and more prone to breaking. Calcium is also vital for nerve impulse conduction and muscle contraction. So, this is why I say you want to make sure that you have adequate calcium in your diet and you have adequate vitamin D in your diet so that. In your diet and in your body, so that it can absorb as much of that calcium as possible, so that you can deposit the calcium in your bones to strengthen them, but you don't have to resorb it when needed because you always get a constant supply. If the blood levels of calcium start to decrease and you're not taking in any through food, then your body has to go to your bones in order to bring the calcium levels in the blood up so that you can have adequate amounts so your nerves can work and so that your muscles can contract, like not only your skeletal muscles, but your cardiac muscles. When those levels get low, it's the parathyroid hormone that's going to help to raise blood calcium levels. And then you have another hormone called calcitonin that's also going to affect how much blood calcium you have. These are examples of normal bone, osteopenia. So you can see how it's not quite as sturdy as normal bone, but it's not in a really bad position yet. But then osteoporosis, you have lots more spaces where you can damage the tissue even easier. And this is just another picture of it. Uh, Two bone slices side by side. This is your healthy bone, and this is your osteoporotic bone with lots more spaces here, lots more weakened areas here. So we already talked about the infant skull, but I do want to go over it just one more time. Um, the characteristics of a newborn skull are that it is incompletely developed at birth. So you'll notice that babies don't have all of the bones of the skull are not fused together. That is where we get the fontanelles, the soft spots. So, other characteristics of the infant skull, they have a smaller face, their eye sockets or orbits are large, they have a prominent forehead, the nasal cavity and jaw are smaller. The sinuses in newborns or infants are not completely formed yet. And then the bones are more thin and more flexible in the infant skull. As they get older, these things will start to develop. The bones will start getting thicker and less flexible. The sinuses will start to develop. They will grow into their face, their eye socket, their forehead, their jaw, etc. The fontanelles, in the spaces that are not connected, you have this fibrous membranous material that connects the bones. This is the site of intramembranous ossification that will occur once as the baby grows older. This allows the skull to change shape during the birthing process. So again, this allows the baby's big old head to squeeze through that narrow space so that mom and baby don't have as much trauma as baby passes through the birth canal. There are four major fontanelles in the skull that close between the ages of 2 months to 2 years. So the fontanelles are different sizes, different locations throughout the head. And starting as early as 2 months, those fontanelles will start to close. By the time the baby is 2 years old, they're a toddler, that's when all of the fontanelles should have closed by then. So this is an example of your infantile skull and the fontanelle. So the four main fontanelles you have your anterior fontanelle that is located here. So this is at the junction of your frontal bones and your parietal bones in that space there. You have the posterior fontanelle. So your posterior fontanelle occurs here at the junction between your parietal bones and your occipital bone. It is smaller, as you can see, than the anterior fontanelle. You have your posterolateral fontanelle. So it's on the side, but the back posterolateral fontanelle. It's also called the mastoid fontanelle. So you need to know both names, mastoid fontanelle and posterolateral fontanelle. Then you have your anterolateral fontanelle that's also called the sphenoid fontanelle. And again, I need you to know both terms because you will see both terms throughout as you move forward. So changes that occur throughout the lifespan, um, there is a decrease in height that can start to occur about the age of 30. So now, because most of you are under the age of 25, you are still growing, you're still at your optimal height unless you continue to grow. For those of you who have stopped growing, I should say, you are at your optimal height. Like this is the highest that you're going to be. Those of you who are still going through growth spurts, you might get a little bit taller. When you hit 30, that's when your height can start to decrease. Just little bits by little bits. Your calcium level can drop. Your bones can start to become brittle and more prone to fracture. Obviously, this does not all occur at one time, but over the course of life after 30, this can happen. Your osteoclast will start to outnumber your osteoblasts. So remember, class tear down, blast build. So you have more tearing down than you have building of the bones. Your spongy bones start to weaken before your compact bone because remember, it is spongy. It has lots more spaces. Um, bone loss is more rapid in women who are going through menopause. So later in life, that bone loss can be more rapid because of that drastic drop in your estrogen and progesterone. Hip fractures tend to be more common because of these life changes as the person gets older. And then you have these vertebral compression fractures that become more common as a person gets older. That is it for chapter 7.